Hi everyone, Assalamualaikum. In this video, we are going to learn about continuity. A function is continuous when its graph is a single unbroken curve. That is not a formal definition, but it's help you understand the idea. These are the examples for the graph of continuous function. From here, you can see that the graphs are a single unbroken curve or line, right? Now we look at what is not continuous, also called discontinuous. This is the graph of not continuous function or discontinuous function. Okay, we have hole here, or we have jump and hole here, right? And then from here we have asymptote. Okay, look out for hole, jump, or vertical asymptote where the function heads up or down towards infinity, right? More formally about continuity is we can define continuous using limits. In the syllabus of Calculus 1, we will find continuity using limits, right? A function is continuous at x equals to c if and only if number 1, fc defined. Number 2, limit x approaches c fx exists. And then to determine whether limit x approaches c fx exists or does not exist, we have 4 steps. Okay. The first step, we need to find limit x approaches c from the left fx. Okay. Step 2, we need to find limit x approaches c from the right fx. Step 3, we need to check whether limit x approaches c from the left fx equals to limit x approaches c from the right fx. And then step 4, we can conclude whether limit x approaches c fx exists or does not exist. Okay? If this condition is passed, we can continue with step 3. Limit x approaches c fx must equals to fc. Means that the value in step 1 here must equivalent to the value in step 2 here, right? So if the 3 conditions are passed, so the function is continuous at x equals to c, right? In the syllabus of Calculus 1, there are 2 types of question involving continuity. The first one is determine whether the function is continuous at x equals to c. And the second one is find the value of constant, let's say k, if the function is continuous at x equals to c, right? Alright, we look at the first type of question involving continuity. To determine whether the function is continuous at x equals to c, we need to follow these 3 conditions, right? The first condition, fc must define. Define here means the value of fc must equals to any real numbers, right? And then if fc defined, we can proceed with condition number 2, right? Limit x approaches c fx exists. And to determine whether limit x approaches c fx exists or does not exist, we need to follow this step. Okay, we have 4 steps here. First, we need to find limit x approaches c from the left fx. Step 2, find limit x approaches c from the right fx. Step 3, we need to check whether limit x approaches c from the left fx equals to limit x approaches c from the right fx. And then step 4, we can conclude that limit x approaches c fx exists or does not exist. Okay? If this condition is passed, we need to proceed with condition number 3, right? The value of limit x approaches c fx must equals to the value of fc. If all these three conditions are passed, means that the function is continuous at x equals to c. Alright? But let's say condition number 3 is failed, means that the function is discontinuous at x equals to c. Okay? So to determine whether the function is continuous at x equals to c, we must follow these three conditions. Alright? We need to show step by step. Okay? Alright, now we look at second type of question involving continuity. Find the value of the given constant. Let's say the given constant is k. Okay? If the function is continuous at x equals to c. In this case, the function is already continuous at x equals to c. So we no need to follow step by step using these three conditions. But we can jump to this formula. Alright, we can use formula limit x approaches c from the left fx equals to limit x approaches c from the right fx. Okay, no need to follow all these three steps. Right? But we can jump to this formula. If we want to find the given constant and then the function is already continuous at x equals to c. Right? Got it? How to determine limits from the left and limit from the right for piecewise function. Let's say we have a piecewise function here. We have 4 functions for fx for different domain. Alright. So from here we have domain x less or equals to 0. So we can draw a real number line notation with boundary value 0 here, and then we have equal sign here. So at 0 we must color the circle, and then less here means arrow to the left, right? And then for 0 less than x less than 3, it means between 0 and 3. Okay, from here we have 0 less than x. Okay, let's say we read backward, means we can read as x greater than 0. Okay, so from real number line notation for boundary value 0 and 3, at 0 we can put a hole here because there is no equal sign at 0 here. Okay, and then same goes to 3 here. There is no equal sign here, so we put a hole here. Okay, at x equals to 3. And then from here 0 less than x, we can also read as x greater than 0. So from 0 greater than 0 means to the right. And then from here x less than 3 means from 3, less here means to the left. Okay, so that's why 0 less than x less than 3 also means between 0 and 3. Okay, from this real number line notation. Alright, and then for domain x equals to 3, okay, from real number line notation, we only have dot, single dot at x equals to 3. Okay, and for domain x greater than 0, for real number line notation, for boundary value 3 here, we have hole here because there is no equal sign, and greater than 3 here means arrow to the right. Right? And then from here, 0 and then to the left means that limit x approaches 0 from the left fx. So this real number line is for this domain, and this domain is for this function. Means that to find limit x approaches 0 from the left fx, we use fx equals to 1 minus x squared. Alright? And then from the second domain here, we have 0 and then to the right. Okay, so we can find limit x approaches 0 from the right fx, and at the same time 3 and then from the left. So we can find limit x approaches 3 from the left fx using the same function, okay, which is 1 plus 2x. Okay, I repeat, to find limit x approaches 0 from the right fx and limit x approaches 3 from the left fx, we use the same function because this real number line represent for this domain and this domain is for this function or this fx. Alright? And then at x equals to 3, there is no line or arrow to the right or to the left. So we no need to use this function. Okay? We not use this function. Okay. And then from here, we have 3 and then arrow to the right. So we can find limit x approaches 3 from the right fx using this function, which is 7. Okay, because this real number line represent for this domain and this domain is for this function or this fx. Alright, got it? We look at example 1. Given a piecewise function fx equals to 1 minus x squared for domain x less or equals to 0, fx equals to 1 plus 2x for domain x between 0 and 3, fx equals to 6 for domain x equals to 3, and fx equals to 7 for domain x greater than 3. Right? Determine whether fx is continuous at x equals to 0 and x equals to 3. Right, from here, 0 and 3 are the boundary values for the given domain. Right? That's why we need to determine whether fx is continuous at the boundary of the given domain here, which is x equals to 0 and x equals to 3. Alright? Alright, to determine whether fx is continuous at x equals to 0, we recall back. A function is continuous at x equals to c if and only if. Okay? The first condition, fc must define. Okay, we use fc here because we have x equals to c. Right? Now we have x equals to 0. So for the first condition, we can write f0 define. Alright? Alright, to find f0, which fx should we use? Okay? From here, x equals to 0, we can refer from the given domain. Okay? For domain x less or equals to 0, x equals to 0 is included in this domain. So, we need to use this fx. Alright? If we use fx equals to 1 plus 2x to find f0, it is wrong because x equals to 0 not included in this domain. Same goes to 6 and 7. Okay? Fx equals to 6 and 7 also wrong to find f0 because x equals to 0 not included in this domain. Right? But in this case, x equals to 0 include in domain x less or equals to 0. That's why we need to use this function because this domain refer for this function. Right? So to find f0, we use fx equals to 1 minus x squared. Right? So f0 equals to 1 minus, we just replace x equals to 0 into whatever x here. Okay, so we get 0 squared. And then after we simplify, we get f0 equals to 1. 1 is a real number, so means that f0 defined. Right? So the first condition is passed. Okay? So we can proceed with the second condition. Right? Alright, now the first condition is passed. So we need to proceed with condition number 2. Okay, limit x approaches c fx must exist. Okay, to check whether limit x approaches c fx exists or does not exist, we have 4 steps here. Alright, so now we proceed with condition number 2. Limit x approaches 0, fx must exist. Why we use 0 here? Because we want to determine whether fx is continuous at x equals to 0. Right? In this general formula, we use x approaches c because a function is continuous at x equals to c. But now we want to determine whether fx is continuous at x equals to 0. That's why the first condition we use f0 define, and the second condition we use limit x approaches 0 fx exists. Right? To determine whether limit x approaches 0 fx exists or does not exist, we have 4 steps. Okay, the first step, we need to find limit x approaches c from the left fx. The second step, find limit x approaches c from the right fx. And then step 3, check whether limit x approaches c from the left fx equals to limit x approaches c from the right fx. And then the final step, we can conclude that limit x approaches c fx exists or does not exist. Okay, from step 1 here, since we have x equals to 0, so we need to find limit x approaches 0 from the left fx. Okay, so we write limit x approaches 0 from the left fx. From fx here, okay, we are given a piecewise function with 4 fx. Okay, so which fx should we use? Okay, so in this case, we can refer the given domain. Okay, from domain x less or equals to 0 means that 0 from the left. Okay, so to find limit x approaches 0 from the left fx, we use this fx. Okay, so we can write limit x approaches 0 from the left fx equals to limit x approaches 0 from the left, we replace fx equals to 1 minus x squared. Alright, after that, from here, we can solve this limit using direct substitution. We just replace 0 into variable x here. So we get 1 minus 0 squared, which is equals to 1. Right? So our limit x approaches 0 from the left fx equals to 1. Right? Right, after that, we can continue with step 2. Find limit x approaches c from the left fx. In this case, since we are given x equals to 0, so we need to find limit x approaches 0 from the right fx. Right? In this case, we use c equals to 0. So we write limit x approaches 0 from the right fx because we are given x equals to 0 here. Okay, and then to find limit x approaches 0 from the right fx, which fx should we use? We have 4 fx here. Okay, so we can refer from this domain. Okay, 0 less than x. If we read backward, we read as x greater than 0. X greater than 0 means 0 from the right. Okay, so we can replace fx equals to this function. Okay, we replace fx equals to 1 plus 2x. Okay, and then to solve this limit, we just use direct substitution. We replace 0 into variable x here. So we get 1 plus 2 times 0. Okay, equals to 1 plus 0 equals to 1. Right? After that, we continue with step 3. Check whether limit x approaches c from the left fx equals to limit x approaches c from the right fx. In this case, our c or our x equals to 0. So, we need to check limit x approaches 0 from the left fx equals to limit x approaches 0 from the right fx. From here, we get limit x approaches 0 from the right fx. Limit x approaches 0 from the left fx equals to 1. And we get limit x approaches 0 from the right fx also equals to 1. So means that limit x approaches 0 from the left fx equals to limit x approaches 0 from the right fx, which is equals to 1. Right? Alright, after that, we continue with step 4. We need to conclude whether limit x approaches c fx exists or does not exist. From here, we have limit x approaches 0 from the left fx equals to limit x approaches 0 from the right fx, which is equals to 1. So we can conclude that limit x approaches 0 fx, no right or left here, equals to 1. Okay, which is exists. Okay, we pass condition number 2. Okay, limit x approaches 0 fx equals to 1, which is exists. Alright, so we can proceed with condition number 3. Limit x approaches c fx must equals to fc. In this case, limit x approaches 0 because our x equals to 0, fx must equals to f0. Okay, limit x approaches 0 fx from here equals to 1. Okay, and f0 under step 1 from here also equals to 1. So we can write limit x approaches 0 fx equals to f0, which is equals to 1. Then we can conclude that therefore fx is continuous at x equals to 0 because all of these three conditions are passed. Right? So this is the conclusion. Alright? For question A. Right? We have three conditions here. But in condition number 2, to find whether limit exists or does not exist, we need to find limit from the left, limit from the right, and then we check whether the value of limit from the left equals to limit from the right, and then we can conclude that limit exists or does not exist before we proceed with condition number 3. Right? And then if condition number 3 is also passed, so we can conclude that the function or fx is continuous at x equals to 0. Right? Coming up next, continuity. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.